Hi, my name is Harold Russell. I'm from Photonic Systems. Today we're here to demonstrate our STAR technology, which is our simultaneous transmit and receive using a single antenna demonstration. I'm going to use the board here to explain the demonstration setup here. Our technology is based on the STAR box here, which it connects and interface our single antenna to our transmit and receive sections of the demonstration. Our transmitter site 1, which we're going to refer to as the Rolling Stones, gets a signal from an iPad into a commercially available FM transmitter. The antenna output of the transmitter is then connected to the STAR box and is rerouted to the antenna and transmits a signal. At the same time, we also receive a signal, comes in and gets routed out into our commercially available FM radio receiver. All of the components in this demonstration are tuned to 94.2 megahertz, which is a clean frequency on the spectrum. We also tap off a small amount on the receive channel so that we're allowed to show you visually how much cancellation of our own transmitted signal we see. What's nice about our STAR box is we achieve great isolation of the transmit signal on our receive path. This allows us to be able to hear a second transmitted signal of lower power on our receiver while we're broadcasting a larger signal. We use the computer here to turn on and off the demonstration, which allows us to hear the music that we're still broadcasting from Rolling Stones, and we can then show that we can achieve and hear the smaller signal of book on tape. So the demonstration in front of us here on the table here, again, our STAR box with a single antenna. We start with our FM transmitter, and we'll show that we have a signal because it's broadcasting. The green light means it's locked up at the right frequency. We have our iPod, which we get analog audio modulation onto the FM carrier of 94.2 megahertz. It's then, the signal is routed from the back of the antenna port to the front of the STAR box, and then is sent and routed out our antenna. Well, what happens is we receive that signal, it comes back in, and that is routed to our receiver path, which then gets split to here and sent to the back of our FM radio receiver antenna input port. We also show a small portion on the spectrum analyzer, which allows us to do a CW demonstration to show how much cancellation we can achieve. I'll also show that also with our audio modulation on after we show the CW, because it's a lot easier to see the signal. The computer here is just again for on and off control of the demonstration. And then we have our second audio site here, which is again a commercially available FM transmitter. It's set for 94.2 megahertz. It has an iPod that sends a book on tape signal. So what we want to demonstrate is that we're transmitting a large signal, and we'll be able to hear at the same time from a second transmitter, the talking book, over our Rolling Stones music. So the CW demonstration here I'm going to show you here is we're broadcasting a CW tone, no audio modulation on. So you can see that the signal is marked with a marker at the peak. I'll now go over and turn on our STAR box. And right now we're achieving about 65 dB of cancellation here. So that says that we're sending a signal, we're broadcasting a signal, and what we're hearing back in here at the receiver, we've been able to cancel our own transmitted signal by about 60 dB. I'm also going to turn on the signal's audio modulation of the Rolling Stones, and we'll be able to hear it on our FM radio receiver. Now this shows you that, again, we're still broadcasting with a maximum signal, and you can see the FM carrier signal with its audio modulation on there. So I'm going to turn this off, and I'm going to go to the second site so that we can see and hear what we want to be able to hear over our Rolling Stones.
Was now nervous.
Now again, I'm not changing the frequency of our receiver, so our transmitter is now transmitting the book on tape, and we're hearing it on our receiver through our star box. So we're broadcasting over the air to this antenna, and it's being rerouted out to the radio receiver. Now when I go and turn on our transmitter of Rolling Stones, we're going to have a large amplitude signal, and we're going to be hearing only what we're transmitting.
Facts to suit theories instead of theories to suit facts. Dean concludes his book with that thought.
So it takes a while for it to lock up. We have a green light, it's locked up, and now we can see we're swamping, the Rolling Stones transmitter is swamping our book on tape. So I'm going to go ahead and turn on our star box.
Dean's own formative experience.
And very quickly, we're now being able to hear the book on tape transmitter.
Like many people who worked in the White Houses of numerous administrations,
I'm going to demonstrate turning this on and off to show how fast the reset is working.
Together its true nature.
You should be able to instantaneously hear the music and then the book on tape again.
Edges can often be the real discoverers. It is at times the journalists.
To show that I'm not changing any frequency and that we're still broadcasting, I'm going to go over and turn off the second transmitter so that what you'll hear, the receiver is still being able to achieve that signal. The reason why it's still able to hear the Rolling Stones broadcast, even though it's attenuated by 65 to 60 dB typically numbers, is because the dynamic range of the FM receiver. So I'm going to return back on our book on tape. It will take a second to lock up.
Saying it was the one
and now we have the book on tape again.
To a man who, because of age or something else, is
at this point, I thank you very much for the time.